Welcome to our complete guide on equivalent decimals. Equivalent decimals are one of the most critical building blocks in all of elementary and middle school math. Whether you're comparing decimals, ordering them from least to greatest, or adding, subtracting, multiplying, and dividing, understanding equivalent decimals is essential. Today we'll explore what equivalent decimals are, how to spot them instantly, and how placeholder zeros work. First, what does the word equivalent mean? Simply put, equivalent means equal in value, worth the exact same amount. When thinking about whole numbers, 5 and 50 are obviously not equal. Having $5 is very different from having $50, but decimals work a bit differently. Let's look at our first question. Are zero point 0.5 and 0.50 equivalent? To understand why 0.5 and 0.50 are equivalent, let's write both as fractions. 0.5 is 5 tenths, or 5 over 10, and 0.50 is 50 hundredths, or 50 over 100. Notice anything about both fractions? They both simplify to exactly 1/2. Even though they have different names, 5 tenths versus 50 100ths, they have the exact same value. They are completely equivalent. And here is why. Both numbers have a 5 sitting directly in the tenths place. Adding zeros to the far right of a decimal, called trailing zeros, does not change the value of the number at all. It changes the name from 5 tenths to 50 hundredths, or even 500 thousandths. But the 5 never moves out of the tenths place. You can add or remove trailing zeros freely without changing what the decimal is worth. Now let's compare 0.5 and 0.05. Are these equivalent? Let's line them up. In 0.5, the 5 is in the tenths place, but in 0.05, there is a 0 in the tenths place, which pushes the 5 into the hundredths place. 5 tenths is 10 times larger than 5 hundredths, because the digit moved to a different place value. 0.5 and 0.05 are not equivalent. Let's look at 3 quick practice pairs. Pair 1. Are 0.6 and 0.06 equivalent? No. 0.6 is 6 tenths, while 0.06 is 6 hundredths. That 0 pushed the 6 to the right into the hundredths place, cutting this value down. However, if we had 0.6 and 0.60, those would be equivalent because the 0 is just a trailing 0 on the right. Pair number 2. Are 1.75 and 1.750 equivalent? Let's check column by column. Both have one whole unit, both have 7 in the tenths place, and both have 5 in the hundredths place. The second number just has a trailing 0 in the thousandths place. Since trailing zeros on the right do not shift any digits or change the value, 1.75 and 1.750 are completely equivalent. Pair number 3. Are 0.88 and 0.088 equivalent? In 0.88, we have 8 tenths and 8 hundredths. In 0.088, the 0 in the tenths place pushes the 88 back to the hundredths and thousandths place. Because the digits were shifted into different columns, 0.88 and 0.088 are not equivalent. If it were 0.880, it would be equivalent, but that internal 0 changes everything. So just to recap, equivalent decimals share the exact same value. Adding or removing trailing zeros at the end of a decimal never changes what it's worth. But adding zeros between the decimal point and digits move those digits to smaller place values, which changes the number completely. So that's it for today. Thanks for watching. Make sure to like and subscribe, and I'll see you in the next mastery check.